Hi everybody, we're talking about linear regression today. What we're going to be doing is using technology, our TI-84 graphing calculator, and the linear regression t-test on it to find the regression line. So we're going to be using the linear regression t-test to find the regression line. Then we're going to be determining if the mean of the data or the regression line should be used to make a prediction, and we're going to make the prediction. So what exactly is the regression line? So the regression line is the line of best fit. It is the straight line that best fits the scatter plot of the data. The regression equation is written here. Y hat is equal to b sub 0 plus b sub 1 times x. B sub 0 is the y-intercept. B sub 1 is going to be the slope of the regression line. And the regression line is used to describe a relationship between the x variable, or the independent variable, and the y variable, or the dependent variable. Now, what about this part about making a prediction? So, if you remember from that previous screen, we are either going to be using the regression equation or the mean. So how do you determine which to use? If the regression equation is a good model, then we'll use the regression equation. If it is not a good model, then we're going to use the mean. We're going to be discussing this process of how we evaluate that in this screencast. So let's look at an example. If you watched my previous screencast on correlation, linear correlation, you'll remember this example. Sometimes people like to try to predict the temperature outside based on the number of chirps per minute of a cricket. So listed here are the number of chirps in 1 minute and the corresponding temperature in Fahrenheit. So what we're asked is to find the regression equation and then predict the temperature if a cricket has chirped 1,000 times in 1 minute. Our significance level is 0.05. So the first thing I want to do is take that information and put it in my calculator and create this scatter plot so I can see what this data looks like. So remember to do that in the edit. So first I clicked on stat, and then edit is what I'm going to choose. And I'm going to put the chirps per minute in list 1 and the temperatures in list 2. So that means my independent variable are the chirps and my dependent variable is the temperature. Once you do that, to create that scatter plot, what you're going to do, so I have that on this screen, but I'll show you how we got there. So you're going to press on this second stat plot, and you're going to make sure that you put one of these plots on. So if I press enter here, I have the option of turning it on and off. You want it to be on. This is the picture for the scatter plot. We want the independent variable x to be from list 1 and the dependent variable y to come from list 2. And this is just the shape we're going to draw on our graph. And we say that we're going to color it in blue. Some calculators don't have this option. But once you have that all entered in there and you press graph, you'll see this picture. I forgot to mention that you'll want to change the window. So I have the window on this screen, but if you press the window key, you can input these numbers yourself. So where did these come from? So remember, the x variable are the chirps. So I just set a window from 500 to 1300. So the smallest x is 500, the biggest x is 1300. That's just based on this data. I want to make sure it's all represented in this picture. The smallest y value I set is 65 and the biggest is 95. Once again, that's just selected because of the information I was given in this table. Okay, the next step is to find that line of best fit, or the regression line. Okay, so we're going to do that the same way we did the correlation. So in this stat menu, toggle over to tests and scroll down using the arrow key to the linear regression t-test. The independent variable is L1, the dependent variable is L2, and remember this is a two-tailed test. I want to store the regression equation in Y1. To get there, you're going to press vars, Y variables or Y vars, function, and you're going to choose Y1. And then we're going to press calculate. You'll remember from when we were dealing with correlation, we got this similar screen. If I scroll down to the bottom, I can find that correlation coefficient. The correlation coefficient is 0.874. It's pretty close to 1. So this is a pretty good model. We can also tell that from the p-value. The p-value is 0.0046 if I round that to 4 decimal places. The test statistic, remember, is also here, 4.399 rounded to 3 decimal places. So how do I find this regression line? That's also given to me in this list of data. See, the equation is y is equal to a plus bx. That's how it's written on your calculator. The a value is 27.6263 if I round it to 2 decimal places. And that slope, that b value, is 0.0523 rounded to 4 decimal places. And I wrote the regression equation y hat right here on this screen. And so make sure you know how to find those values on your calculator. So I mentioned this already, but this is a pretty good fit. And since that line is a good fit because p is less than alpha, so since it is a good fit, I'm going to use that regression line to make the prediction. So I'm going to plug 1000 in this equation for x, and I get the value of 79.9 degrees Fahrenheit. You can use this regression equation and you can plug it in there. You can also use your calculator. If you press on second calc and value, and you plug in what you want x to be, which we wanted it to be 1000, that regression equation is already stored in y. Okay, remember I chose that when I was actually doing the linear regression t-test. So if I press enter, it's going to give me that value of 79.9. It's just sort of a shortcut. I'd also like you to look at this regression equation. You can see it on this screen, but I also wanted it in the PowerPoint so you see this line really is a pretty good fit. Not all the dots are on this line, but they're pretty darn close. Okay, let's look at another example. This example has to do with Old Faithful. So listed below are the duration times in seconds and the time intervals in minutes to the next eruption for randomly selected eruptions of the Old Faithful geyser in Yellowstone National Park. Find the regression equation and then find the best predicted interval after time for an eruption with a duration of 253 seconds. And then we're going to be asked, how does it compare to an actual eruption duration of 253 seconds and an interval after time of 83 minutes? So first, we're going to predict what the interval would be after a eruption of 253 seconds, and then we're going to compare that to one that actually happened. Okay, so here's all that information. Once again, I need to put that into my calculator using the edit menu. So enter those data points into list 1 and list 2. So list 1 in this example is our x variable, or independent variable, which is going to be the duration time of the eruptions, which remember was in seconds. And list 2 is going to be the duration, or the interval after, the number of minutes until there's another eruption. So those are all entered in here. Once again, I want to look at the stat plot. So I'm going to press second stat plot, make sure that plot 1 is on, make sure that you have list 1 as your x variable, list 2 as our y variable. And then when we look at the graph, we can see our stat plot. Oh, I forgot to mention the window. I set this window. The x values go from 100 to 300. Remember, I'm making sure that I have all these x values represented, and the y values go from 80 to 110. Once again, making sure that I have all of these values represented. So do you think that these dots, form a line? I don't know. We got a major outlier here. This part isn't even really linear. If I just look at these 3 points, yeah, it's kind of linear. So I'm not expecting something really good from our regression line. But let's go ahead and find that regression line. So just like before, that's under the stat menu, tests, linear regression t-test. Make sure you have the x variables, the y variables set. It's always going to be this two-tailed test. Make sure you store the regression equation in y1 so you can see it. And here's the data that we got. Scroll down and you can see our R value. Our R value is not very good, 0.046. R is very close to 0. It's not close to 1. It's not close to -1. Look at that p-value. It's very high at 0.921. That's a very high value for p. But the regression equation still comes out. The regression equation is 90.19 plus 0.0067 times x. That's the a and the b value, which we're plugging in this equation. So y hat is 90.19 plus 0.0067x. This is not a good equation. If you look at the line drawn, you can see it right here. So if you look at the line right here, it's not covering all of those points. We got 3 points that are not on that line. Because that regression line is not a good fit, we need to use y bar, or we need to use the mean of the interval after times. So what we're going to do, we can still do that on our calculator. We have all the data in there, so that's the best way. But we have to go back to what we learned way back in I guess it was the first chapter that we studied. And we're going to calculate the one variable statistics for list 2. Why list 2? Because remember, that's where the interval after times are. And we'll press calculate. And the mean of those times is 91.7. So our best prediction for a duration of 253 seconds, we expect the next eruption to occur 91.7 minutes later. And that's based on the average of these numbers. So how does that compare to the actual eruption duration of 253 seconds, which was 83 minutes? It's fairly close. Not exactly close, but fairly close. That average is not a great predictor, but it's kind of a predictor. So anyway, I just want to summarize. We looked at 2 different examples in this screencast. One where we used the regression line and one where we used the mean. Go back through this video to make sure it's clear to you when you use which method. Good luck.